Hey y'all, I'm Gracie and this is Lab 2, Lines of Charge. Since charge cannot be created or destroyed, objects can transfer charge through contact or by simply being near another object. This is the conservation of charge. Gravitational force, electric force, and especially the principle of distribution of charges were implemented during this lab. From Lab 1, it's known that due to the repulsive nature of two assumed equally charged tapes, one of them can actually float above the other. Using the point charge model, the total excess positive charge can be calculated. Because the magnitude of gravitational force must be equal to the magnitude of electric force if one tape is floating above another and the momentum of that tape is not changing. The calculated charge from these assumptions is 1.221 times 10 to the negative 7th coulombs. Finally, VPython was used to show how treating the tapes as lines of charges affects the value of Q. The calculated charge from this is 1.93602 times 10 to the negative 7th coulombs when modeling the tapes using the principles of distribution of charges. The experiment. The momentum of tape B is not changing. Therefore, the net y component of the forces on tape B is 0. The mainly vertical forces on the floating portion of tape B are the electric force from tape A and the gravitational force from the Earth, as you can see in this free body diagram. This is when modeling the tapes as point charges. The length of the tape is 0.224 centimeters. The mass of the tape is 0.00447 kilograms. The magnitude of gravitational force is calculated using this equation to get 0.0439 newtons. We know the magnitude of electric force is equal to the magnitude of gravitational force, so they are the same value. And the charge of tape B is done using this equation and then manipulating it to get this equation to finally get the value of 1.221 times 10 to the negative 7th coulombs. The coding. Before we talk about the coding, I just want to mention the assumptions that you have to make to actually do the coding. There's no air resistance, and the charge is evenly distributed across the lengths of the tapes. This is drastically different from Lab 1, where we just had point charges being modeled. As you can see here, this is now tape B, and this is now tape A, and you actually have all of these electric field vectors from tape A on tape B. This is the electric force, and this is the gravitational force. Our calculated charge is 1.93602 times 10 to the negative 7th coulombs. The magnitude of electric force and gravitational force are equal, and their values are 0.0438507 newtons. Next, this is actually what went into the coding and how those values were calculated. First, you had to calculate the E field. This is the mass. This is actually the final estimated charge, and this is how the electric field was actually calculated. This is how the tapes were created, what went into their masses, their position, their charge. Next, we have calculating the electric force and the electric field, all the equations and values that went into getting those arrows. Next, we have the net electric force and the net gravitational force and how they were calculated and how those arrows were shown. And finally, the conclusion. The conservation of charge allows charge to be transferred between objects, and the distribution of charges allows the tapes to be modeled as a length with charge evenly distributed across the tapes, rather than as point charges as was done in Lab 1. When the tapes are modeled as point charges, the charge of tape B is 1.221 times 10 to the negative 7th coulombs. When the tapes are modeled as lines of charges, the charge of tape B is 1.93062 times 10 to the negative 7th coulombs. These estimates differ because in the point charge model, gravitational force directly cancels out electric force because there's only vertical components in that model. However, in the line charge model, the electric force can have horizontal and vertical components as tape B can be at an angle to tape A. The horizontal components cancel as shown by the coding model, and only the vertical components are left to cancel out the gravitational force, which causes the greater charge seen in this model. The line charge model is closer to the real value of the charge than the point charge model because tape has length and is not one single charge, which is exactly what the line charge is modeling. Thanks for watching.